Hey Cavs, how you guys doing? So we are about to start my favorite topic, and this is called stoichiometry. Okay, so stoichiometry basically is you're calculating how much you're going to produce or how much you're going to need for a particular chemical reaction. In most labs that we have done up to this point, you're not really worried about how much you're using, or I've told you how much to use. After this section, you're actually going to be able to calculate how much of the different reactants you're going to need, or how much of the products you would make in a chemical reaction. This is, like I said, this is my favorite subject. And the reason why is it's basically a culmination of all the topics from nomenclature on. So it's going to involve nomenclature. It's going to involve a little bit of the calculation section that we did, where we did mass equals number of moles times molar mass, and hashtag equals little n times big N, although to be honest, that formula is not used as often. It's also involving word equations, balancing chemical equations, a little bit of predicting the products, and that all mixed together into this section. So what you're going to find is this section is basically a good measuring stick as to whether you're going to be well suited to take chemistry in the future or not. So the two parts that I always tell people to look at is how well you understood the bonding section, which is section 5, and then how well you're doing in stoichiometry, which is section 9, plus a little bit of the stoichiometry that we would do in section 10 and in section 11. And those are your best measuring sticks as to how to do this. So what you're going to find in stoichiometry is we're going to build up on it. So the lesson that you're going to get today on mole to mole stoich is the building block of any stoichiometry that we do, okay? And then in lessons beyond this, what will happen is I will just add another layer of difficulty to it. But this lesson is the most basic and is the most important that you're able to understand. So let's go inside and we'll go through it, okay?
Okay. So what's going to happen here is I am going to go through two of the examples that are on this note that I will be sending you. Okay, so you'll get a video of me explaining it, plus you'll see in words how to solve these things. And between the two, you should be able to understand it. While you're watching this video, I would make sure that you have this sheet handy to go through it, and then it certainly doesn't help if you have a scrap piece of paper to kind of go through it as I am as well. So here's the first example, and in this one you'll notice that I gave you the chemical formula, so that makes this thing a lot easier. There will be examples where I don't give you this. So if I don't give you the chemical reaction, then what you're going to have to do is you're going to have to take the description, convert it into a word equation, and then from a word equation, then you're going to go to a chemical equation. So that's where nomenclature comes into play. In this particular one, there's not a lot of nomenclature that you have to know. You do have to know that oxygen is obviously O2, phosphorus is P, but that's pretty basic, and I don't think anyone in grade 11 chemistry would have difficulty with that. So this is how we solve for stoichiometry. The first thing we're going to do is we are going to rewrite the chemical reaction, and we're going to use the whole width of the page. So I'm going to have phosphorus, oxygen gas, and then I'm going to have diphosphorus pentoxide on this side. Okay? Now, the next thing I want to do is I want to be able to balance this. Now, finally, you do not have to show the inventory. You can just balance by inspection. If you find that you can't balance it, then certainly don't be a hero and use the inventory to be able to get this. Now, I have an odd even thing going here, so I know that if I double that, there's 4 phosphoruses, 4, 10, and there we go. Okay, so that's stuff that we learned in section 8. Now, the next thing we're going to do is we are going to make columns. Now, this is something unique that I do. You'll find that in most universities, they don't solve stoich using columns like this, and a lot of high schools, they don't. They just do a lot of calculations. I like showing these columns because in my mind, it's very logical. any calculation I do here will be for P2O5. Any calculation I do here will be for oxygen, and obviously any calculation I do here will be for phosphorus. So I just like the way it's set up like this, okay? Now, what I'm going to do is I'm going to go through, read the question, and then put down all my givens or what I'm asked to solve for. So right away, you're gonna see that I'm asked to solve for the moles of the product. So moles is little n. Now this is going back to section 7, okay? And I'm telling you we are starting with 2.6 moles of oxygen, which is little n for oxygen, 2.6 moles. And then I'm also telling you that we have lots of phosphorus. So I'm putting that there. So that basically means that I'm not running out of phosphorus, okay? How much I produce of the P2O5 is strictly going to be based on my oxygen. Now, whenever you jump from one column to another column, you have to do what's called a mole to mole ratio. And that's the basis of what we're trying to do here. Now, in order to do a mole to mole ratio, what you're going to do is you're gonna go line equals line, all right? Now, these coefficients, technically, they are telling you that you need 4 phosphorus atoms, you need 5 oxygen molecules, and when you react them together, you will produce 2 P2O5 molecules. Now, that isn't very practical because you're not going to just be able to take 4 atoms, okay? So this ratio of 4 to 5 to 2, instead of looking at them in terms of atoms and molecules, which technically is what it means, we are also able to say that this would be 4 moles of phosphorus, 5 moles of oxygen molecules, and 2 moles of P2O5. Now remember, moles and molecules are not the same thing, right? If you have 1 mole, you have 6.02 times 10 to the 23rd. But by dealing with 4 moles, 5 moles, and 2 moles, those are quantities that we can actually use. So it's just a more practical way of doing this, okay? So once we have line equals line, on the bottom, we are going to put the original mole to mole ratio that is between these 2 columns. I'm not worried about phosphorus because, well, basically we have lots of it, so the reaction really isn't dependent on it, and you are only comparing 2 things. You never look at all 3 things. So the original ratio is 5 to 2, and I try to keep them in the same order that they appear here. So this is my O2 side, and this is my P2O5 side. Now, I don't have 5 moles of oxygen. I am only using 2.6. And what I'm basically doing is, I know I have to maintain a 5 to 2 ratio. So if I have 2.6, what do I need here to maintain that 5 to 2 ratio? So when you do that, all right, and you do the calculation, now I do this generally in 1 step. I don't bother doing it in more than 1 step. So I'm going to take the 2.6, I'm going to multiply it by 2 and divide by 5. Now, personally, I would never show that work. I would just come up with the answer here, which is 1.04 moles. So if I used 2.6 moles of oxygen gas and I dumped in a lot of phosphorus, I would produce 1.04 moles of P2O5. And that's basically answering the question, okay? In the second example, again, this is nice because I gave you the chemical reaction here. So the first thing we're going to do is we're going to take the chemical reaction, write it out again, and I'm going to spread it out the width of the page. Just allows me more spaces to write things down. All right, now the next thing we have to do, we have to balance this. So I have an odd even thing going with the oxygens again. So if I double that, 4 irons, 6 oxygens there. So 3 times 2 is 6 oxygens. I have 3 carbons there, which makes that a 3. So when I've done that, it's balanced. So notice the steps that I'm doing this. I write out the chemical reaction, spread it out the whole width of the page. Then I balance it, okay? And now I'm going to set up my columns. So your columns go underneath the plus sign or the arrow. And again, if I didn't give you this, then your first step would actually be to get the right chemical formulas and then set up a chemical reaction and balance it. My next step is going to be writing out all my givens. So I am interested in the number of moles of both reactants. So I'm after little n for my iron 3 oxide, and I'm also after little n for carbon. So in this example, I want you to find the number of moles of the reactants that we need to make a particular amount of product. And in this case, we want to make 4.6 moles of iron. Now remember, the original ratio is 2 moles of iron 3 oxide, 3 moles of carbon. And when you react them together, you're going to make 4 moles of iron and 3 moles of carbon dioxide. All right. Now, whenever we go from column to column, we're only looking at going from 2 columns. So I'm going to go from this column to this column, and then I'm also going to go from this column to this one. I always go back to the original so that if I make a stupid math mistake in this column, I'm not carrying it over into this column. All right? So whenever you're doing a multiple ratio, line equals line. On the bottom, you're going to keep the original ratio that was there, which in this case was 3 to 4. Okay? Now remember, this is carbon, and then this is the iron side of things. Instead of 4 moles, I actually have 4.6 moles, and I want to know what do I need there to maintain a 3 to 4 ratio. So when I do this, I'm going to take 3 times 4.6 divided by 4. That's how I would do that. And just to kind of save on that, because I would just solve it in one step, you're going to get 3.45 moles. Okay? So that means that if I want to use 4.6 moles of this, I would need 3.45 moles of this substance. Now, let's try this one here. Again, I am going to go from this column to this one. Now, you could go from this one to this one, but if you make a math mistake here, you're pretty much automatically guaranteeing this one is also going to be incorrect. Okay? So we go line equals line. My original ratio is 2 to 4. Instead of 4, I have 4.6. How much do I need? And I would highly suggest you kind of fill them in exactly like I do. I do this, if you were to watch me as your chemistry teacher solving this, I don't just go n over 2 and 4.6 over 4. I go 2 to 4, 4.6, and then n. So when I do this one, I'm going to multiply 4.6 times 2 and then divide by 4. And when I do that, I end up with 2.3 moles. All right, so that tells me that if I were doing this chemical reaction, if I measured out 2.3 moles of ferric oxide or iron 3 oxide, and I also measured out 3.4 moles of carbon, reacted them together, I would make 4.6 moles of iron. Now you might be wondering, well, what about carbon dioxide? And I generally do that because it wasn't asked for in the question, so I don't do any calculation. If you did a calculation here, you would never lose marks, but what you will see is you'll see this. And that's telling you that you're wasting your time. Waste of time is what it stands for. It's not a bad thing. I'm just letting you know that you're doing more work than is required. So if you have difficulty finishing a test or an exam and you see a lot of whats, then you know that that's probably why you're running out of time, because you're doing way too much. Okay? Now, the last thing I want you to understand, and this goes back to section 8, is in this particular example, I'm going to start with 2.3 moles, and it's going to go down at the end. I'm not going to have any moles left over. Okay? That's what this question is basing it on. How much do you need? Well, I know I'm going to end up with this column. I'm going to end up with 3.45 moles. is what I'm going to start with. And again, in the end, I'm going to have 0 moles to start or to end with. Okay, I'm going to use both of these things up. Now you might be saying, well, wait a minute, you're starting with different amounts. But remember, they're used at different amounts. Okay, carbon is used faster than the ferric oxide. It's a 2-to-3 ratio. So for every 2 of these you use, you are using 3 of these. Okay? The other interesting thing is with products, we are going to start with nothing. We haven't made any yet. And over the course of the reaction, we are going to make 4.6 moles of this. Now, we have no idea how much of this we're going to make. We didn't have to calculate it, but I do know that we are going to start with 0 moles of this. We just don't know how much of this you're going to make. This part down here, this really is a way to check to see if you understand what you're doing. Now, we can do that back to the first example as well. Now, I know that at the start, we have lots of this. And in the end, we're going to have leftover. That's the whole point of having lots of it. We don't worry about it running out. At the start, we're going to have 2.6 moles of this, right? It's a reactant. We use the reactants up. This is all going to be used up. We're not going to have any of this left, okay? Now, at the start of this one, there were 0 moles. It's a product. So we haven't made any yet. And over the course of the reaction, we are going to have 1.04 moles at the end. So if you can do this, this really shows that you understand what's going on in the chemical reaction and what you've calculated. So what you'll find is that when I send you my answers, I do this a lot. Depending on the test and on the exam, sometimes I will make you do this, the start and the ending amount, and then sometimes I don't. Highly suggested that you do it just for practice. And if I'm not marking it, I will just take a look at it, tell you if you're doing it correctly. And again, you're not going to lose any marks for it unless I specifically ask for it in the question. Okay? So good luck on this. Make sure you ask questions if you do not understand it, because this is vital for you understanding what's going to be going on in section 9. Take care.